All right, so a few things I wanted to do today. To wrap things up, we'll be done. We'll be good to go. We won't have to do anything else outside of today to get you ready. Like I said, I'll make that review for us. So we'll have that probably tomorrow. I'll put that together. Send that out so you can start working on it if you'd like. But today should do it. And today I just want to touch on a couple things, and they're pretty quick. Let's see what order did I want to do them in this one. Probably the trickier one first. Okay. Solving equations that have absolute value. So absolute value equations. And I think we know enough about absolute value to be able to just kind of jump right into this. Let me know if anything I say kind of gets lost somewhere. But if we have just like the absolute value of x equals 5, something like that, we're trying to figure out what number I can put on the inside so that its absolute value is 5, right? An absolute value is really just distance away from 0 on the number line, both positive and negative. So a lot of the times we're going to get two answers. Not necessarily a positive one and a negative one, kind of depending on what's happening on the inside. But a setup that includes the positive version and the negative version of this number right here. Because a number that could work inside here is just 5, right? The absolute value of 5 is 5. But the other number that could work would be -5, right? The absolute value of -5 is, of course, equal to 5 as well. And so when you're solving absolute value equations, and we're going to keep it simple, where the absolute value is the only thing on that left side. There's nothing out here being multiplied. There's nothing over here being added or subtracted. What we can do right away, and this is what you want to know, is to set up an equation that doesn't have the absolute value in it. You kind of want to break out the x and everything else that was inside. This one is just x, of course. Kind of break out everything that's inside and give yourself an opportunity to find those two answers, right? One that's going to give you 5, and one that's going to give you -5 in this case. And so here's my setup. Here's my plan. Here's how I go about these. I drop the absolute value on the left-hand side, but I create an opportunity for me to find both of my answers by dropping a plus or minus in front of the right side. Okay, so we'll lose the absolute value, plus or minus on the right. Okay, and what that'll do is it'll give me two possible equations, right? X is equal to 5, or x is equal to -5. And I'm done. And you certainly could have stopped right there with the plus or minus. That would have been fine. But sometimes what's happening on the inside is more than just x. And so we might have a step or two of work to do after the fact, right? What we might have is something like the absolute value of x plus 3 is equal to 5, okay? And so what we just want to try to figure out is what x values are going to work to make that happen. And so it's not about necessarily finding +5 and -5 as your solution, but trying to figure out what numbers inside here would create 5 and would create -5. And so because there's nothing else on that left side with the absolute value, we can drop the absolute value from the left and put a plus or minus in front of the number on the right. Because if I could make x plus 3 equal to 5, then yeah, absolute value is going to work. And if I can make x plus 3 equal to -5, then I take the absolute value of that, and of course I'm going to get 5. And so what I like to do is I like to just kind of split my work into two. Instead of dealing with the plus or minus the whole way through, it's up to you. You can do it as early or as late as you like. I like to do it right away, where I break this into two possible setups, right? One where the inside is equal to the positive, and one where the inside is equal to the negative. And I just solve those separately. And because the equations that they're going to give us on this final and the ones that we really have to deal with really aren't that complicated, you're not creating a ton of work to get yourself to x equals 2 and x equals -8, right? Plug 2 right there. 2 plus 3 is 5. Absolute value of 5, good. Drop -8 right there. -8 plus 3, negative 5. Okay, absolute value of negative 5 is equal to positive 5. We're good. Okay. Hopefully that makes sense. I just want to do one more, and then I'll give you a couple to try. Make it a little bit more interesting to look at. Let me make sure I'm not doing ones that I've planned on doing already. Let's do like 4x minus 2. Absolute value of that is equal to, let's do something besides a 5. Let's go like 10. Okay. And if you have a good strategy on how to do these, the process gets a whole bunch easier. And I really like my setup in trying to say, you know what, if I can just get myself to a point where I can lose the absolute value and set up an equation or two, in this case 2, that's going to do what we want, then I'll just solve those 2 separately. Okay? So my plan is always make sure that the absolute value is isolated on one side. It will be, and it is, so we're good. Okay? In my very next step, drop the absolute value and put a plus or minus in front of that number that's on the right-hand side. Okay? And I like to just break it apart right away. As soon as I put that plus or minus in front, I'm going to break this one equation that has plus or minus into 2. One where I use the positive version and one where I don't. Okay. 4x minus 2 is equal to 10. And 4x minus 2 is equal to negative 10. And then I just do whatever I need to do to solve that. And if the numbers work out really nice like these, great. If you end up with fractions or decimals, fine, that's okay, right? Whatever works, works, right? In this case, add 2 to both sides, divide by 4, and we do get a nice number there. Add 2 to both sides and divide by 4, we actually end up getting a nice number there as well. And I just kind of made that up. So I'm glad that worked out, but it's okay if it doesn't. If you get 1/3 and negative 5/2 or whatever it is, it's okay. We'll just see whatever we do. Cool. Nice. 2 for you to try. I will share my screen, but it's also already on Canvas. I put a link on Canvas for today's practice. Okay, click on that. It'll take you to here, and just to keep our focus where it is, I'll hide these other 2 for now. Just solve those 2. Okay, solving these absolute value equations. Absolute value of 2x minus 1 equals 7, and the absolute value of 3x plus 5 equals 2. Okay, I'll come over here, and I'll start doing them. Okay. Try those out, and you should be good to go. And that's it. They're not going to get super, super difficult. So here's the practice. Should be relatively quick. I don't know if the numbers all work out really perfectly, and that's okay. They might not. So. Drop your name in the chat if you have not done so. So I have to take attendance for today. This will be our last meeting. Like I mentioned before, we won't have to meet tomorrow, which is good. we'll get everything done today that we need to feel like we've covered everything ahead of the final that will take the Wednesday, the week after Thanksgiving. Okay, we'll take Monday and Tuesday to review. And if you haven't heard, I know I've said it a couple times, but in case you haven't caught it just yet, everybody is on a Monday, Wednesday, kind of a cohort A schedule for the 2 weeks after Thanksgiving. Okay, Monday and Wednesday will be live. Tuesday and Thursday will be the asynchronous days. I will definitely be on personally on Tuesday, and we'll probably go live on Thursday and Friday that week, just because we'll be starting trig, and I do not want to waste any time. But your other teachers might have their own schedule, their own plan. So just keep that in mind going forward. Once we get back from Thanksgiving break, Monday, Wednesday live days. You really want to make sure that you log on to any of your teachers' Google Meets, including ours, of course. And then Tuesday, Thursday, Friday will be those remote days where it kind of depends on whatever your teacher decides they want to do. We will be live, I would expect, every day of those 2 weeks. I need to get as much trig taught as I can. And I mean, even looking back, I probably should have done that more often this year so that we could have gotten this done earlier. But hindsight is 2020, of course. So there you go. There's practice 1 and 2. I got 4 and -3, and -1 and -7/3. Right? You don't have to get both one positive and one negative, because the idea is to make a positive number in here, make a 2 or make a -2, and however that works, right? The numbers kind of control how that's going to work. So. Pretty simple concept, but definitely worth reviewing. Something that doesn't come up much past Algebra 1. You see it in Algebra 1, and then we kind of move past it. So, all good? Any questions? I'll leave that up there for a second. I'm gonna stop presenting for a moment. So you can get a better view of that while I erase the board over here, and we will do the next one. Hopefully these mini lessons are going okay. Hopefully you feel like it's worth the time. I certainly do. I know that looking at this final as closely as I have over the last couple of days, that although the questions aren't necessarily difficult, they really aren't. They're all different. For the most part. So I wanted to make sure that we took some time to do it. So there you go. Okay. Next idea. We solved absolute value equations. Now let's solve some radical equations. Okay. And the reason that I'm saying radical equations and not just square root equations is because it's the same process no matter what that root is. Square roots, cube roots, fifth roots, 12th roots, whatever. The process is still the same. Now, I think the one on the final is just a square root, so we won't have to worry too much about applying kind of different ideas. And that's what I'll focus on today, is just square roots. But just know that it works whether it's a cube root or a fifth root. You just have to take the right power to undo that. Okay. Let's just go for it. Okay. I like to keep it simple to start. Square root of x equals 5. Okay. Again, just trying to figure out what number I can put underneath that square root to make it work. Okay. If the tables were turned and it was x squared, right? Not a square root, but x squared, we would use a square root to undo that, right? That's the case where we would need the plus or minus, because when you take a square root, we don't know if the answer that you came from with x squared was a positive number to start, and then we squared it so it stayed positive, or a negative number to start, and then we squared it and so it became positive. Here, we know it's positive. Okay, we've already undone the square, right, with the square root. Okay, so we're not going to have plus or minus here at all. Okay, we're only going to be looking for that one possible answer. Okay. But you want to kind of be comfortable recognizing that square and square roots are inverse operations of each other, and so that's what we're going to use. If you had a square, you'd use square root. Well, here I have a square root, right? And so what I'll do is the opposite of that. I will take the left side and take the right side and square. Okay, because the square and the square root will cancel each other out. X equals 25. And you're done. Okay. Now, it doesn't matter what variable they decide to use, right? We could call it the square root of m minus 4 equals 2. That's fine. It doesn't have to be an x. It could be whatever letter they decide, right? We'll just use that letter the whole way through. Don't change it to an x. Stick with whatever that letter is, okay? You're going to see in calculus, we might start using different variables to represent actual things. T for time, or h for height, or s for speed, or v for velocity, or whatever we decide to use. So don't get stuck on x too much. But the nice part about these kind of setups, when they have, just like the absolute value, we wanted to isolate that before we did anything. We want to make sure that that square root is the only thing on that left-hand side so that we're not squaring things we shouldn't be. And it is, so we're good, right? I can just take this left side, take the right side, and I just need to break that m out, right? Or that x or that q or whatever letter they decide to use. I don't want to break it out from underneath that square root, and square is the best way to do that. Again, no plus or minus necessary. I just kind of bring down what was underneath that square root, the radicand, C-A-N-D is what it's called underneath the square root. And then I just have to square it. Whatever that right side is, I'll just square that number, see what I get. And then solve, right? This one was done, right? It was just x, okay? Here, I still had some more underneath that square root attached to that variable that we're solving for. So let's just add 4 to both sides and get whatever that answer is. That's it. There's not much more to it. I'll do one more just so you can see it. I'll do a slightly more complicated one that just has a little bit more going on underneath. But the reality is you won't have to worry about isolating the square root, which is really nice. Okay. So, the square root of, I just want to make sure I don't do one that I've already thought about doing. Sorry, I'm just sneaking a peek at my little practice. Okay, cool. 3t plus 2 equals, what number have it? 4. Right. Square root of 3t plus 2 equals 4. Again, square root's already by itself on one side, so we know that we're in good shape to just jump right in and solve it. We don't have to do any special kind of isolating to get it by itself. So I can just square it. I can just go for it. I can square the left side, square the right side. If that was the cube root, for example, I would do x cubed. I would cube both sides. If it was to the the fifth root, I would raise it to the 5th power. Whatever that root is, you want to make sure that the roots and the exponent that you're using just match. Okay, but they're just square roots. So we're good. Square and the square root cancel each other out. So 3t plus 2, 4 squared is 16. And then solve it, whatever you need to do to solve it. And we're not breaking this into 2 equations like we did with absolute value over here, because there is no plus or minus. This is just one nice answer that we're looking for. Let's subtract 2 on both sides, divide by 3. Okay, 14/3, fine, no big deal, right? Can't use that decimal because it goes on forever. And that's fine. I'll simplify the fraction if I need to. 14/3 is as simple as it gets, and we're good to go. Okay, pretty simple. Just a little bit of algebra. I'll give you a little practice. If you want to go back to that today's practice that I posted on Canvas, you'll see what I'm about to show you. 3 and 4, solving radical equations. Okay. Try those. Should be pretty quick. And then I'll do one last thing. We've talked about it. We did it in chapter 1, but there were a couple people that mentioned that they weren't super comfortable with it. So I just wanted to mention it. If you do decide that you are comfortable with it, then you're good. It'll be, we'll do a little bit of practice in case, and I'll just show it to you now. Finding equations of lines that are parallel and perpendicular to a given line through a given point. Something that some people know really well, and you don't have to do this practice with us now. Some people just wanted to see it one more time to make sure that they have a good base. So I'm going to do that as our last thing, going back to chapter 1, because it's been a while. But first, let's do practice 3 and 4. Bring you guys with me. Thanks again for showing up. Appreciate it. X minus 1. Okay, I'll stop sharing so you can get a better look at it. Ooh, that's cool. Nice. Watch that all day. Awesome. Any questions? All good. 17 and 5 over 2 or 2.5. Just know that because it's multiple choice, they might put the fraction or they might put the decimal. They'll just have to pick the right one. Okay, they're not going to put both. They wouldn't put both. Cool. Let's do one more thing, and then we'll be done. College algebra will be done. Then we get to start trig. Okay. Last thing. Finding equations of lines that are parallel or perpendicular to a line that's given through a point that's given. So they're going to give us a line, they're going to give us a point, and they're going to say, hey, be parallel to this line, but make sure you go through this point. Or be perpendicular to this line, but make sure you go through this point. Okay? Equations of lines. Okay, chapter 1 for sure, if you need to go back and look at this. And I'll make sure I put some on the review as well. The answer is in slope-intercept, not point-slope. Okay, so you want to make sure that you can get yourself to that y equals mx plus b form. The nice part is they're going to start us in y equals mx plus b as well. So they're going to give us a line, y equals 2x minus 1, and say, let's go through the point, like 2, 3, okay? So they give us a line. Here it is, 2x minus 1. And then they say, okay, here's the point we want you to draw your next line through, okay? And they want it to do one of two things. And they're not going to ask for both. They're going to ask for one or the other, but I'll show you how to do both. they're going to ask us potentially to find the line parallel to this one that goes through this point. Right? If your two lines are parallel, if your slope of this line is 2, the slope of the line parallel, it looks like 2 L's right next to each other, is also 2, right? If two lines are parallel, they have the same slope. Right? And so this is the slope that I'm going to use in the new line that I figured out. Okay? How to do that is kind of up to you. Do you want to start in slope intercept and solve, or do you want to start in point slope and solve? Either one's fine. I want to show you both so that you can pick whichever one you like. Okay. I'm a little partial to point slope. I just think it's easier to start with an equation and then just rearrange it so it's solved, rather than create an equation to solve, get an answer, and then have to rewrite the right answer. Here's what I mean. So here's 2 ways to do it. Okay, you could start in slope intercept. Okay, and what I mean by that is you start like this: y equals mx plus b. And you plug in what you know. I know m, I know x, and I know y. Okay, so I'm just going to drop those in. So 3 equals 2 times 2, but we don't know b yet, and that's what we're going to try to solve. Okay, so 2 times 2 plus b. And you just solve for b. Okay, so 2 times 2 is 4. Subtract 4 on both sides. And b is equal to -1. Okay, but that's not the answer. The answer is the equation of the line that has this slope with this y-intercept. So you have to rewrite it: y equals 2x minus 1. And I mean, that's obviously not the worst thing in the world to do, but you do have to remember to get yourself to there. Okay? And that works great. It really, really works. Okay. Whether b ends up being nice like this, or a fraction or decimal, it's okay. Whatever it is, it is. Okay. The other way to do that would be to start in point slope, and then just rearrange the equation so that it looks like this one. Okay, so you would start y minus y1 equals m x minus x1. Okay, with the slope that we know we're going to use, because we picked the parallel ones, so the slopes are the same. And they're going to give us the first line, our kind of reference line, in slope, slope intercept, so we know what we're doing. This is just x1, y1. Right? There's the point, a specific point along the way. And I just drop in what I know, and I rearrange stuff so it's going to look like this. So I'm going to say, okay, y minus y1, so that's 3, equals m, so that's 2, parentheses, x minus x1, which is also 2. And this would be fine if this was like a free response kind of question, but everything's multiple choice, and the answers are all slope intercept. So you're just going to want to use this and just distribute the 2 that's in front and slide that 3 over. Okay, so I'm going to do that in that order. I'm going to multiply in that 2. Right? I'll distribute this 2 onto the inside, and then I will add this 3 to both sides. And of course, I'm going to get myself to the same answer. It's the same line, so no big surprise. Okay, so pick whichever one you like. Personally, I like this one. And so that's the way I'm going to do it here for this perpendicular example. I'm just going to use starting point slope, because then if I start with an equation and I can just rearrange it and be done, then yay, I'm done. I don't have to remember to rewrite it. But I'm good either way, right? Your best is your choice, right? Whatever works better. Okay. Now they ask us potentially to do the perpendicular version of the same question. And they're only going to give us one or the other. They're going to give us a line and a point and say, find the one parallel or find the one perpendicular. Just do whichever one we're asked to do. And so the only thing that we have to remember is that if the slope of our line, and this says perpendicular, if the slope of the given line is 2, like this, the slope of the line, and here's the symbol for perpendicular, it's an upside down T. The slope of the line perpendicular, we just have to know how to do that, okay? Perpendicular slopes are opposite or negative reciprocals. So switch the sign. If it was positive, make it negative. If it was negative, make it positive. And then flip that number upside down. Okay, it was 2 over 1, so now it's 1 over 2. And that's the slope that I'm going to use in this one. Okay, I'm still going to use this same point, right? They gave me that point, that 2, 3. And then I'm just going to use it. Okay. I'm going to do it in point slope. Okay, but if you want to go in slope intercept, you do it the same way. You set up y equals mx plus b. You drop in y, m, and x. See what you get. Solve for b. Okay. So for me, I'm going to use this y minus y1 equals m x minus x1. Because if I drop in what I know, I can just rearrange it and set it equal to y, and I'll be done. Okay, y still minus 3 equals, now my slope is the only thing that changes in this problem. X minus 2 is still minus. So y minus y1 is y minus 3. Careful with your negatives there. If you had an x or a y was positive or negative, you would, or if it was negative, of course you want to switch the sign. And then I just go for it. Okay. Same process. I'm going to distribute whatever that m is sitting in front. So y minus 3 equals negative 1/2 x, and then negative 1/2 times negative 2 is positive 1. Okay. And then I'll add this 3 over to the other side. So y equals negative 1/2 x. That's it. Okay. You might end up with decimals or fractions. Fractions are always good when it comes to lines because slope, right? Down 1 over 2, down 1 over 2, down 1 over 2. It just makes graphing those really easy. So I like to stick with fractions. I'm a fraction kind of person when it comes to most things anyway. Because it's integers. I don't have to worry about 0.073265 or whatever. I just like to write it as one number over. Cool. So just a quick little recap from chapter 1 that I know shows up that I just wanted to make sure you saw. If you'd like to, if you think you need to, there is one more bit of practice. So it looks like 2 questions, but it's really 4. All right, 1 parallel and 1 perpendicular. 1 parallel, 1 perpendicular. Okay, so if you think you need it, if you want to just try maybe even just the first one, great. But if you think you're good and you're ready to go, then you are good to go. Okay, we're done. College algebra, we are done. We will review Monday, Tuesday, and we will take our final virtually on Wednesday. And I will send out details about how that's going to happen. But it's going to happen during our class time. If you're in second period, you come to second. Okay. If you're in fourth period, you come to fourth, because I'll be releasing the test to just you in your section and nobody else. Okay. You will attend a live Google Meet, and your camera will be on as if we were sitting in class. Okay. If that's an issue for you, then please let me know. We will find a way to make it work, but this is a college final. Okay, I need to preserve the integrity as much as I can. So, so there you go. Okay, I will work through the solutions to 5 and 6 for those of you that want to stick around and just make sure you're doing it right. But if you're good, you're good. I send you on your way. Happy Thanksgiving. Stay safe. Enjoy the time with family, and know, here we are, level red. The idea is to try to just stick with the people at home. So, FaceTime and Skype with friends and extended family. But let's get these numbers down a little bit. Okay. Thank you guys. Appreciate it. I'm going to do some answers, but if you want to go, you are good to go. 2x minus 1. Did I really do the exact same one? Huh. The points are just different, 3, 2. That's fine. There you go. I will stick around for these next 10 minutes of class in case you do have any other additional questions. Maybe there's something that I haven't done yet that maybe you want to see. What I'll do, actually, now seems like a really good time. I will post the topics for the final. CU College Algebra Final Exam. Okay. So just under announcements, the most recent one, let's say CU College Algebra Final Exam topics. I'll also put an assignment on Canvas for this, so you have a place to upload your work on Friday. If you do have any scratch work that maybe you want considered for partial credit, If you get a question wrong, but you show me some good work, I can find you some points there. So that'll be there as well. And on that assignment, I'll post all the details. When exactly, and links to the Google Meets and all that kind of stuff. Okay. I will also post a review as soon as I write it. And I'll work on the solutions as well and post those for us to check out. Okay. There you go. Let me know if you need anything. I'm here.
Thank you, Rosie. Happy birthday, too.
Oh, thanks. Yeah, nice way to celebrate.
I have a question. So, on Tuesday, I got marked absent for all my classes. Is there a place I'm supposed to go and like mark my attendance for, like when we're here on Wednesdays and Mondays?
So the days this week that you are normally remote are still the days where you want to go on the Infinite Campus and take your own attendance, as we have been all year, right? With that option on Infinite Campus. On your normal in-class days this week, you should have been just kind of doing whatever your teacher needed you to do for that day. Like for me, if you come to the Google Meet, then you're present, right? But some teachers have assignment-based attendance. Like you need to log on and work through these 10 problems and submit them by 3 o'clock, and then you're present, or whatever it is. So you just kind of want to make sure that with each of your classes, you're checking that Canvas page for that kind of daily plan, whatever that is. And every teacher does things a little bit differently. I know for me, it's just, checking. I put in an announcement every single day for what we're going to do. So,
yeah.
So that's it.
Thank you.
Now, when it comes to the weeks after Thanksgiving, those 2 weeks after, Monday and Wednesday are the live days. Tuesday, Thursday, Friday will be the remote. For me, we'll do something every day, but
yeah.
For other teachers, it just kind of depends on what they want to do.
All right, thank you.
You got it.
Bye, Rosie. Happy birthday.
Bye. Thanks, Megan. See ya.
Bye. Happy Thanksgiving.
Yeah, you too. Happy Thanksgiving.